Hello everyone, myself Ayan. So in today's session, we are going to see few more used cases of centralized control plane policy. In today's session, we are going to cover traffic engineering, wherein we will see end-to-end path tracking. So we will discuss what is end-to-end path tracking and how to configure and verify it. The second used case in today's session that we are going to see is route leaking. So we have discussed that VPN1 and VPN2 maintain separate routing table. And in case if we want to have these, if we want VPN1 to communicate with VPN2 and VPN2 to communicate with VPN, so in that case, we will be using route leaking. So we are going to see that for today's session. And apart from that, we will also see arbitrary or per VPN topologies, wherein we will have hub and spoke topology for VPN1 and full mesh topology for VPN2. So these are the used cases that we are going to see for today. So starting with end-to-end path tracking. So what is end-to-end path tracking? So let's say this is my Dubai router. And this is so the router on the left is the Dubai router and router on the right is my London router. Okay, there is VPN1 connected between this router and VPN1 connected behind this router. Here as well we have VPN1. Now I have a security stack, let's say firewall connected over here. Now I want the traffic from Dubai, VPN1 traffic from Dubai going towards London router should go through my hub site and then from the firewall and then to the London router. So I want my traffic from Dubai VPN1 subnet going towards the London. I want it to go to the hub first and then to the firewall and then to the London branch. Apart from that, I also have T-log details of my London router. My Dubai router has T-log details of London router and London router also has T-log details of Dubai router. They can also form the direct tunnel up between them. But my requirement is as such that my VPN1 traffic should first go to the hub, firewall, and then to the destination. So this can be achieved very easily, but the problem is, let's say I have this topology. Okay, I have this setup wherein my VPN1 traffic will first go to the hub router, then to the firewall, and then to the destination. But what if this path itself goes down? My Dubai router will not be aware that this path is down, and even though I can have a direct tunnel between them, this Dubai router will still forward the traffic over here. But at the end, the packet will not reach to the destination because because the connectivity between T3 and T2 itself is down. So to overcome this problem, there is end-to-end path tracking. So what we can do is we can configure our topology in such a way that we will be preferring this path initially, but if this tunnel goes down, my Dubai router will form a direct tunnel with the London router. So this is called end-to-end path tracking, wherein we will be tracking the paths from T1 to T3 and then T3 to T2 till the destination. So with this configuration, with this topology, there are 4 options that we can configure. The first option is strict option. In this option, even if this path goes down, This option is initially used wherein my security is the utmost priority. Let's say if this path goes down, but I do not want the traffic from Dubai to reach London without being scanned. In that case, I will use strict option. So what will happen in strict option is if this path goes down, my traffic will not be able to reach the destination, and that is accepted because security is my utmost concern. The second used case is the primary option. In primary option, the traffic will first go to the hub, then it will go to the destination. Okay, and if this path goes down, my Dubai router will form a direct tunnel with the London router and start forwarding the traffic from here. My third option is the backup option, wherein direct tunnel will be preferred first. My Dubai router will send the traffic directly to the London router, and if this path goes down, it will forward it from the hub site. And the last option is ECMP, wherein both the tunnels will be up. Both the tunnels will be up. My one packet will go from here and the other packet will go from here. So there will be a load balancing between both the tunnels. And if one of the path goes down, the other path will be preferred. If this goes down, this path will be preferred, and vice versa. So this is uh, all about end-to-end path tracking. Let's see how we can configure it in our lab. So if I go here, what I want here is, in this lab, what I will do is, for this subnet, let's say for Dubai VPN 1 subnet, if my Dubai VPN 1 subnet wants to reach to London VPN 1 subnet, it will go through the hub. And if any of this, if the intermediate path goes down, my traffic will still reach here, but then it will be dropped. So in that case, my Dubai router will form a direct tunnel with the London router, and the traffic will go from internet and then to the Dubai router and then to the destination. So initially, it will prefer the internet path, and if my internet link goes down, direct tunnel will be formed. So let's go ahead and do the configuration for this. So before proceeding, let's see what are the lists that we are going to need. So the first list that we are going to need is prefix list, wherein we will create all the subnets of my Dubai router, which is Dubai VPN1 prefix, wherein I will call 172.16.63.100/32. Apart from that, I will call 172.16.62.100/32, 172.16.61.100/32. So these are the subnets that I will call. Apart from that, I will also call 172.16.60.0/24. I will create another list for London site, VPN1 prefix, 73.100/32, 70 2.100/32, 71.100/32, and 70.0/24. Apart from that, I will also create a TLOC list wherein I will mention hub TLOC for internet. In this, I will call the system IP of my hub site biz internet, which is the color, and then IPsec, the encapsulation that we are using. Apart from that, I will also create a site list wherein I will call Dubai and London site list, or rather branch site list. Branch sites, and I will call site 60 and 70 in this. So these are the lists that we are going to need. Let's go ahead and create it. So to create the list, I will go to configuration, policies, the custom options. I will create a list. First, I will create prefix for Dubai VPN1 prefix. These other subnets I will call here add. I will create one more list for London VPN1 prefix. /73, 72, 71, and 70.0/24. Next, I will create a TLOC list, hub TLOC for internet. IP address will be 99.99.99.50. Color will be biz internet. Encapsulation will be IPsec. There will be no preference. Click on save. Apart from that, I will need one site list. I see that I already have a site list for this branch. That is it. And before proceeding with this traffic engineering, we will have to make the changes on my HO India router, and we will have to allow traffic engineering on this router. Okay, so for that, I will go to my configuration templates. In the feature templates, in the feature template, I will search for VPN 0 of my hub router. Here I see VPN 0 for my hub router. I will edit it. In the service section, I will enable traffic engineering. Click on new service. Service type will be traffic engineering, TE. Click on add, update. Now this template will be pushed to my HO India. Let's verify the difference. Okay, here we see that we are enabling traffic engineering service on my HO India router. That's it. No other changes are being made. Configure device. So the template has been pushed successfully. Let's go to the policies and create a new topology for end-to-end path tracking. So for that, I'll go to configuration, policies, custom options. I will create a new topology. I'll give the name as end-to-end path tracking. In the sequence type, I will create a sequence for OMP routes. In sequence 1, I will call the prefix list. I will call Dubai VPN 1 prefix over here. In the action section, I will accept. Here I will call the TLOC hub TLOC internet, and in the TLOC action, I will also call TLOC action over here. In the TLOC action, we see there are four options. The one that we discussed: strict, primary, backup, and ECMP. Okay, so we will be selecting primary because our main goal is to send the traffic to the HO first and then to the destination. Okay, if we wanted the tunnel to have between the traffic to go between Dubai to London, and then if this fails, if we wanted it to go to the hub, we would have selected backup. So here we will select as primary, save match actions. We will create one more sequence rule wherein we will call the prefix list of our London. Actions will be accept, and the TLOC will be hub TLOC for internet, and the TLOC action will be primary. Save. The default action here we will click on accept because we want all the other TLOCs and all the other routes to function as it is. We do not want to make any changes on it, right? So we will be selecting the default action as accept. If we select the default action as reject, our topology might get impacted. So in this case, we will select as accept and save control policy. Now we will go to centralized policy. We will add a policy. We've already created the required lists. We will click on next. We will call the topology that we have created in this section end-to-end path tracking import. Click on next. Again, click on next. give the name as end to end path tracking. We want this policy to be applied to our Dubai and London router, and the functionality of rest of the topology will be as it is. So we will create new, call it a new site list, and in the outbound direction we will call site branches. Click on add, save policy. Now we see that we already have this policy running that we configured yesterday. So we will quickly deactivate it and take our pre-checks. Let's deactivate, and once this is deactivated we will take a pre-checks on the router. See that the policy has been deactivated. Show running config policy. Still see this policy in our vSmart. Let's give it some time. Okay, so we see that it is deactivated now. Let's go to our vmanage and preview the policy. Okay, so in this policy, in the sequence one, we are matching the route that is mentioned as Dubai VPN prefix, and the action is set to accept. Apart from that, we are giving the TLOC as hub TLOC internet, meaning to reach this prefix, we will have to go via hub TLOC, and if that path is not available, we will use the direct path. In sequence 11 as well, if Dubai router wants to reach London prefix of VPN1, the action is set to accept, and the TLOC that it should prefer is hub TLOC, and the TLOC action is primary. So if the hub TLOC is not available, they can form a direct tunnel between them. And default action is set to accept. And below that we have the list that we have created. And we are applying this policy in outbound direction, to side branches. Okay. Before activating, let's quickly go and verify the current setup. So show OMP routes for VPN 1. So let's check the path for OMP routes on Dubai router for VPN 1 subnet. So if we see here, We are getting 172, 16, 70, 71, 72, and 73 subnet, and they are reachable directly via London path, via the tunnel, and there is no hub and spoke as of now. So they are directly reachable with each other. Apart from that, let's check this on our London router as well. Show OMP routes VPN1 pipe tab. So if we see on our London router, these are the subnets that belongs to Dubai router, and they are reachable directly via Dubai TLOC. Now we want it to reach via the hub TLOC, and if the hub TLOC fails, we want it to reach directly. Let's do a quick trace as well. I'll trace 172.16.63.100. So this is my, that's the wrong trace. Let me do it from here. So from my site London 1, I will trace 63.100. It should go directly between from the Dubai router. So from the London router, it has reached to Dubai router, and then till the site London router. So let's activate the policy and verify. So this is the policy that we are going to activate. I'll click on activate. So the policy has been pushed successfully. Let's verify. Okay. Let's go to the vSmart and check. Show running config policy. Yes, we see the end-to-end path tracking is available. Let's verify the output. So if I do show OMP routes on my BR Dubai router, so these London routes should now be reachable via hub TLOC, which is 99.99.99.50, and only with biz internet, not via MPLS. So if I see here, even though we are directly reachable, but it is preferring the hub TLOC with biz internet for 70 network. Similarly for 71 network, similarly for 72 network, and so on. Let's verify the routing table as well. So in the routing table as well, we can see all these belongs to my London branch. These subnets belong to the London branch. and it is taking the TLOG IP of my hub router, and it is only installed biz internet routes. Apart from that, if I do show OMP routes, show OMP route with the subnet IP address and subnet mask, I will see that the ultimate TLOG, the TLOG that it is preferring is 99.99.99.50, and the ultimate TLOG is 99.99.99.70. So if this TLOG goes down, it will start preferring this TLOG. Let's verify the same on London as well. Show OMP routes for VPN1 by 10. So for 60 network, these are the 60 network that belongs to Dubai. Here we see that this path has been installed, and the next hop TLOG is my hub router and preferring biz internet. Similarly for 61 network, this is what it is preferring, and the next hop TLOG is my hub router and biz internet, and so on for 62 and 63 as well. Hub TLOG, biz internet. Let's verify it in the routing table as well. Show IP routes for VPN1 pipe tab. Okay, I see that it is preferring biz internet via hub TLOG, and this is the Dubai prefixes. So let's quickly do a trace from the London router. This is my London router. Earlier it was going directly from London to Dubai and to the destination. Let's trace it once again. It has reached the London router, then to the hub router, then to my Dubai router, and then to the destination. Now let's turn this router off and see the behavior. So what will happen if I turn off this router is, currently this path is being preferred. This path is being preferred, and then again it is coming from here till here. Okay, so now if I turn this router off, it should start preferring the MPLS link and directly to the London, and it will not go to the hub. Okay, let's turn this off and observe the behavior. So now I've turned this router off. We'll wait for a few seconds, and then we will check the OMP and the IP routes, and then the trace. So if I do show OMP routes now, it is still showing, it is not updated. We'll wait for a few more seconds. So it is still on, I believe. Let me turn it off. So it was still preferring the same path. We did not turn it off. Okay, now I've turned it off. Let's see the behavior now. We'll give it a few moments. Okay, here we go. So now we see that it is preferring the direct TLOC. So now this router is turned off. This router is turned off. Now if the traffic wants to go to the 60 subnet from the London, it is preferring the direct path. So that is what we see here. So my BR Dubai is preferring direct TLOC if it wants to reach the London subnet. So from my BR Dubai, these are the London prefix, and now it is preferring the direct TLOC and via MPLS path because the internet path is down. Let's verify it on the London router as well. So from my London router as well, if it wants to reach to the 60 subnet, it is preferring direct path from the Dubai TLOC and it is using MPLS color. Let's do a quick trace and verify the output. Okay, now we see that the first hop is my Dubai London router, the second hop is the Dubai router, and then to the destination. So this is how the path end-to-end path tracking works. So if we would have selected the backup path in the TLOC action, if we would have selected the backup path in TLOC action, it would have preferred the direct path between Dubai and London. And if this would have gone down, it would have gone to the hub via MPLS and then to the destination. instead of primary, we would have selected strict, and if this path goes down, the traffic would have been black holed. It wouldn't have reached destination since we do not have since we have not selected primary and strict. And in case of ECMP, my one traffic will go from the hub and the other traffic will go directly. So that is how this end-to-end path tracking works. Let me turn this router on. Go to the policies and deactivate, and then proceed with route leaking. So let's deactivate this policy. Show running config policy. Okay. So let's proceed with the second used case, which is route leaking. So if I go to my topology, the okay, so what is route leaking? So route leaking is a concept wherein we intend to send the routes beyond their scope. So in our case, VPN 1 routes are not communicating with VPN 2 routes. Okay. So in route leaking, what we do is we leak routes from VPN 1 to VPN 2 and vice versa, so that they start communicating with each other. Route leaking is only applied on service routes. So there are service VPNs. So there are transport VPNs, which is VPN 0, and there is management VPN, which is VPN 512. My route leaking concept does not apply on these VPNs, and it applies only on service VPNs. Apart from that, my route leaking is always applied in inbound direction. And to make use of route leaking, we use an option called export to. Okay, in our policy there is an option called export to. So we make use of this policy, this option, to leak routes between VPNs. So in our case, so these are the HO India routes 50.0/24 and 51.0/24. This both these routes belong to VPN 1. Both of these subnets belong to VPN 1. This subnet also belongs to VPN 1, and this subnet also belongs to VPN 1. Let's say these all the subnets of my Dubai are some sort of applications, and these also are the applications that belongs to VPN 2. So my VPN 2 users, these are my VPN 2 users sitting in London, and these are my VPN 1 users sitting in London. users, and these are also users, and here also these are the users. Now users from VPN 1 are using these applications from remote sites, and users from VPN 2 are using these subnets as their applications. Now these two VPN 1, there is a need in the organization wherein my VPN 1 users should now have access to my VPN 2 subnets and VPN 2 applications. So it is not possible to deploy another applications in VPN 1, so as they already have their applications in VPN 2. Similarly, my VPN 2 users want to use these applications. So in that case, what we do is we leak routes from VPN 2 to VPN 1, so that users sitting in the VPN 2 will now be able to access the applications in VPN 1, and vice versa. So to make this, we will be make this topology work. We will be using the route leaking options. So for route leaking options, what are the lists that we are going to need? As I mentioned that this this policy will be always applied in inbound direction. So we will be needing a site list wherein we will be calling all the sites. So for the site list, I'll create all site and mention 50, 60, and 70. Apart from that, I will need a VPN list wherein I will create VPN 1 and VPN 2. These are the sites that I will need. So let's go ahead and create the required lists. Go to my vmanage. Let's go to custom options list. Here I will create a site list, new site list, all sites, 50, 60, and 70. Click on add. Apart from that, I'll go to VPN and create a new VPN list, VPN 1, and give the number as 1. After that, I'll create another VPN list, give name as VPN 2, and the VPN number will be 2. So click on add. Once this is done, I will go ahead and start creating the topology. Click on add topology, custom control, and give the name as route leaking. In sequence type 1, I'll create route, and in sequence 1, I will match the action as VPN 1. Okay, I'm calling VPN 1 in my match action. My actions will be accept, and here we see that option is export to. I'll make use of this option. And now it is asking in which VPN list do you want to export this VPN 1. I will select as VPN 2, save match action. So now what we have did here is we have exported VPN1 to VPN2, but then we also want to export VPN2 to VPN1, right? So in that case, I will create one more sequence rule wherein I will call VPN list 2 in the match, and the actions will be accept. I will be exporting it to VPN1. Save match action. Apart from this, I want all the topology, all the routes to function as it is. I do not want to make any changes on the TLOGs and other OMP routes. So in that case, I will select the default action as accept, save match action, and then save the control policy. Now we have created the topology. Now we will go ahead and create the policy. I'll click on add policy. We've already created the required lists. I'll click on next. In the configure topology and VPN membership option, I will import the topology that I've just created. Import. Click on next. Again click on next. We'll give the policy name as route leaking. And I will call this policy in inbound direction to all of my sites, so that all the VPN1s and VPN2 are merged with each other. Click on add, save policy. Let's quickly preview this policy. So in this policy, we have given the name as route leaking. In sequence 1, we are matching all the routes from VPN1 and exporting it to VPN2. Action is accept. In sequence 11, we are matching all the routes from VPN2 and exporting it to VPN1 with action accept, and default action is also set to accept. Apart from that, we have the lists over here that we have created, all sites with 50, 60 and 70. We have VPN lists and these prefixes. So this prefix, it will take by default because we have only mentioned it as VPN1. We have not specified any routes. So what it will do is it will call all the prefix list from VPN1 and export it to VPN2. And lastly, we have applied this policy in inbound direction to all the sites. Click on OK. Let's verify. We've already checked we do not have any running config policy on the vSmart one. If we go to vSmart 2 and if we do show IP route VPN1 pipe tab, we see only 172.16 subnet is present and my VPN2 subnet is 192.168. So there is no VPN2 subnets in my VPN1 routing table. I will verify my VPN2 routing table as well. So here as well, I only see 192.168 subnet. I do not have any VPN1 subnets in my VPN2 routing table. I will verify the same on Dubai router as well. Here as well, I do not see any VPN2 routes. VPN2 routing table, there is no VPN1 routes. Let's go to site Dubai 1 and check if I can ping any of the subnets from VPN2. My site Dubai 1 belongs to VPN 1. I'll try to ping 192.168.63.100. My 63.100 belongs to site Dubai 2. I'll check if I am able to ping it. I'm unable to ping it. I will check for 73.100 as well. And my 73.100 subnet belongs to VPN2 of site London. So I'm not able to ping. I'll do this checks from London site as well. Ping 192.168.73.100, which belongs to VPN2 of London branch. And I will ping 63.100, which belongs to VPN2 of Dubai branch. I see that VPN1 and VPN2 are completely isolated. So let's enable this policy and check the behavior. Okay, so the policy has been successfully pushed. Let's verify it on my vSmart. Okay, I see the control policy as route leaking. Match route from VPN1, export to VPN2. Match route from VPN2, export to VPN1. Default action is accept. Let's verify the routing table on my Dubai branch. I first verify my VPN1 routing table. Now I see that my VPN2 routes are also available in VPN1. So these are the VPN2 routes that belongs to my Dubai branch, and these are the VPN2 routes that belongs to my London branch. And I can see that I'm directly able to reach to them via London branch, London router. So this is for VPN1. I'll verify the same for VPN2 as well. So in the VPN2 as well, I can see my 172.16 subnet is present, meaning VPN1 to VPN2 route leaking has worked for my Dubai router, and they are reaching to each other directly via BFD sessions. Let's verify the same from London router as well. So if I do show IP routes VPN1, so in VPN1, I see 192.168 subnet that belongs to VPN2. and to show IP route VPN2 to check the routing table for my VPN2 subnet. So in VPN2 as well, I can see VPN1 routes. I should also be able to get my VPN2 routes on my HO India router. Because we have applied it in inbound direction. Show IP routes for VPN1 pipe tab. So now I see the VPN2 subnets are present in VPN1 on my HO India router as well. So if I do show IP route VPN2, I will not get any output because we have not created any service VPN2 on my HO India router. So the final check would be to check the connectivity. So from site Dubai 1, what I will do is I will ping my 63.100, which belongs to VPN2 of my Dubai branch. I can see it is reachable. Let's check with 73.100 as well and do a quick trace on this IP. Okay, so I can see that it is being reachable internally. Let's verify it from the London router as well. I'll ping 73.100. I see it is reachable. And then I will check for 63.100 and this is also reachable. Let's do a quick trace for 63.100. Should go via Dubai router. So we see that it is first going to the London router, then to the Dubai, and then to the destination. So the VPN1 to VPN2 route linking for London and Dubai is working as expected. From HO India, let's try to ping 61 the subnets that belongs to VPN2. We see that it is reachable, the VPN2 subnets. Let's check for 63.100 as well. We see that 63.100 is also reachable. If I do the trace for 63.100, it should go directly to the Dubai router and then to the destination. Similarly for 73.100. Okay, so we see that VPN1 and VPN2 has worked, the route leaking concept has worked as expected. So if I go and deactivate it and then check, these subnets should not be able to reach with each other. Deactivate this. So the policy has been deactivated. Now, if I go to Dubai, Dubai router and check VPN1 routes, I will not see any VPN2 routes. So the VPN2 routes have been removed. I do not see any 192.168. Similarly for VPN2, there is no 172.116 dot subnet over here. So this is all about route leaking. So the next used case that we are going to see is arbitrary or per VPN topology. So we have seen that the VPN1 are maintaining a separate database. So now with per VPN topology, what we are trying to achieve is, so with VPN1, we want the topology to be full mesh. So with VPN1, we want the topology to be hub and spoke, and for VPN1, VPN2, we want it to be full mesh. Meaning, if I want to reach any routes from Dubai to my London routes, the traffic should go from the hub and then to the destination. If any of these routes try to initiate a traffic with these routes, it will first go to the hub, then to the London, and then to the destination. But any users initiating traffic from VPN2 of my Dubai branch till VPN2 of my London branch, it should go directly from Dubai to London and not from the hub. So this is what we are trying to achieve with per VPN topology in this used case. So for that, let's create the list that I will be needing. So the first list that I will be needing is the VPN list. VPN list with VPN1. The second list that I will be needing is hub tlog, wherein I will create 99.99.99.50. I'll give the color and the encapsulation. Similarly, I will create another tlog because I have two connectivity, that will be biz internet and IPsec. The last prefix list that I will need is the site list, wherein I will create branch sites for 60 and 70. So these are the lists that I will be needing. So let's go ahead and create the required lists. And go to configuration, policies, custom option, lists. What I see is I should be having all of these lists already present because we have did used cases, but let's verify it once again. Starting with the VPN, I already have VPN1 list. If I go to tlog, I already have hub tlog for MPLS as well as for biz internet. And the last thing that we need is site lists. If I go to site, I see that I have site branches and I've called 60 and 70 site ID in it. So as of now, I have all the lists that is required. So what we will do is we'll go ahead and create the topology. For the topology, I'll go to configuration, policies, custom option, topology, and in the topology, I will create custom control topology. I'll give the name as per VPN topology. In the sequence type, I'll call route sequence rule. In the first sequence rule, I will call VPN1. Okay. In the VPN list, I will call my VPN1. In the actions tab, I'll click on accept and I'll call tlock of hub tlock. So by this sequence, what I am telling is by this sequence, I'm telling any VPN1 list should prefer hub tlock. I will be applying this policy to my Dubai and my London router. So if my routes from VPN from Dubai wants to reach to London in VPN1, it will prefer hub tlock. I'll click on save action. That's it. That is all what I want. Apart from that, I will go to default action and my default action would be set to accept because I do not want to change any behavior of other OMP routes and the TLOC routes. So I'll click on save match actions, save control policy. I'll go to configuration policies, click on add policy. We've already created the list. In the topology tab, I will import the existing topology, the one that I have created for VPN topology. Import. Click on next. I'll give the name as per VPN topology. Description will also be the same. And I will call this topology in the outbound direction to my branch routers. So this policy will be applied to Dubai and my London router. Click on add, save policy. Let's preview this policy. This is my per VPN topology preview. So in sequence 1, we are matching routes from VPN1 and telling it to go via hub tlock. And default action is accept. And this policy is applied to my side branches in outbound direction. I'll click on OK. For proceeding, let's verify if there is any policy that is running. There's no policy. And let's check on the Dubai and London router. show OMP routes for VPN 1 pipe tab. So from my Dubai router, if I want to reach London router, I am preferring a direct path to my London router, and I see that this route is also installed in my routing table, and the path that I'm preferring is biz internet and MPLS. Similarly, for 71 network, these two routes are installed in my routing table, and that is also directly from the London TLOC, and it is preferring MPLS and internet. So for my third subnets, I can see these two routes are installed in the routing table, and the TLOC IP is my London TLOC, one with MPLS and the other one with biz internet. Similarly for 73.100, these two routes are installed. First one is from the London TLOC via biz internet and MPLS. So this is the current behavior. Let's quickly check the routing table for VPN1 as well. Okay, so I see that all my VPN routes are preferring direct path. All my VPN1 routes are preferring direct path. Let's check for VPN2 routes as well. Show IP route VPN2 pipe tab. So if I see my VPN2 routes, they are also preferring direct path. So once I apply the policy, only my VPN1 routes should be affected, and they should go from the hub, and the VPN2 routes should not be affected. Okay, let's verify it on the London router as well. So from London, if I want to reach 60 subnet, okay, it is preferring direct path via Dubai TLOC. Two routes are installed, one via MPLS and internet, and same is the case for the 61, 62 and 63 subnet. Let's check the routing table. So in the routing table as well, it is preferring direct path, one via MPLS and one via biz internet. Let's check for show IP routes VPN2 as well. My VPN2 routes are also preferring the direct path, and this should not be affected even after activating the policy. I'll do a trace from my Dubai router, site Dubai 172.16.73.100. It should take the direct path from Dubai to London. Okay, so we see that it is preferring the direct path. We'll do the trace from London router as well. 63.100, which belongs to site Dubai 1, VPN 1. So we see that even this route is preferring the direct path. So let's activate the policy and verify the output. So this is my per VPN topology. I will activate it. So the policy has been pushed successfully. See, the status is true. Let's verify it on vSmart. Okay, we see per VPN topology has been pushed to vSmart. And in sequence 1, we are matching routes from VPN 1 and setting the TLOC action to hub TLOC. And the default action is accept. Let's verify it on Dubai router first. So if I do show OMP routes in VPN 1, I see that the next hop TLOC for 70.subnet is set to my hub TLOC. And it is preferring two paths, one via MPLS and other one with internet. And I see that it is also installed in the routing table. Similarly, for 71.100, I see two routes are installed in the routing table, and both of them have the next hop TLOC to the hub router, one with MPLS and biz internet. Similarly, for 72.100 and 73.100, there are two routes. Both of them have the next hop TLOC to the hub router, one with MPLS and other one with internet. Let's check the routing table. Okay, so in the routing table as well, we see the next hop TLOC is 99.99.99.50, which is my hub TLOC, and the color is MPLS and biz internet. Let's check for VPN2 routes. They should have full mesh topology. They should not go via hub router and they should have direct path till the London router. So if we see 192.168.70.0, we see that it is preferring the direct path from 99.70, and it is also installed in the routing table. Similarly, for 71.100, two routes are installed. Both have the next hop TLOG to London router. This means my VPN2 is having full mesh topology. Let's verify for the London router as well. If I do show IP route VPN1 pipe tab, I see the routes installed, but the TLOG IP is set to hub TLOG. And if I do show IP routes for VPN2, they are going directly from the Dubai TLOG. Let's do a trace from Dubai router for VPN1. It has reached the Dubai router. It is then going to the hub router. Then to the London router. And finally to the destination. Let's check it from site London 1 as well. It has reached London router. Then to the hub router. The next is Dubai router. And then to the destination. Let's trace from VPN2 router as well. We will trace 192.168.73.100. This IP belongs to my site London 2, which is in VPN2. I'm tracing it from site Dubai 2. So they should have a direct path and should not go via hub router. So 60.1 is my Dubai, 70.1 is the London, and then to the destination. So with this policy as well, we have verified The VPN 1 is working as hub and spoke, and VPN 2 is working as full mesh. So this is all about per VPN topology.